out square roots today, and the first thing that we should take a look at is square roots and squaring are inverses. Kind of like adding and subtracting are inverses. Those two operations undo each other. Multiplication and division are inverses. They undo each other. Squaring and square roots will undo each other. And if we're ever solving for a variable that's squared, we can use a square root to solve for that particular variable. We'll talk more about that later, especially with like Pythagorean theorem and things like that. But if we look at the square root of 16, the answer is 4. And we know that. But really what the square root of 16 is asking us to figure out is what to the second power equals 16. So we know that 4 fits in there because 4 squared, or 4 to the second power, is 16. But some of you are looking at that second kind of way to look at this right here, and you're saying, Mr. Gibbons, there's another answer. And you would be correct, because x could be 4 as we know it, but x could also be negative 4, because negative 4 times negative 4 is also 16. We are not going to deal with the negative answers so much this year, but for future reference, just know that there are 2 different answers for this particular problem. You'll deal with both of them in the future as you grow in your mathematical careers. So we'll be talking about the positive answers, but just know that that's out there. Okay, so with square roots, let's take a look at some examples. All right, just 4 from here. So the square root of 81. We're looking at what times what gives me 81, or what to the second power gives me 81. This would be 9. And 9 times 9 gives me 81. Square root of 1. What to the second power would give me 1? 1 times 1. My third example here has a negative hanging out on the outside. This just means that whatever you come out with your square root, you're going to look at the square root of 16 by itself. And we get 4, but this comes out negative because the negative is hanging out, which is kind of like what we were talking about with those powers too. If you have a fraction under a square root, you can split this up so that it looks like this. As long as that square root applies to the whole fraction, you can split it up into 2 different square roots. So I can take the square root of 9 and get 3, and then the square root of 25 and get 5, and there's my simplified answer. Another way to look at that is what to the second power gives me 9/25. But yes, you can, as long as that square root applies to both the numerator and the denominator, you can split that up. So these are just some very basic examples of square roots.